So we are starting off with linear convolution, and we'll look into a problem of linear convolution. We'll solve this problem using three methods. One is a tabular method, then we are going to use a formula method, and then we will do the graphical method. So these three questions can come as part of your exam, and you should probably answer it accordingly. If it's a short answer question, you can solve the question using the tabular method, or if it is a descriptive one, you can use formula or graphical, whichever is being asked. So some prior information that we need before doing the problem. So x of k is 1, 2, 3, 4 and h of k is 1, 5, 7. So as we have already looked, L1, which is the length of sequence x of k, it will be 4. L2, which is the length of sequence h of k, will be equal to 3. So that will make the output sequence's length equal to 6, which is calculated using the formula L1 plus L2 minus 1. So n, which is the length of the output sequence, can be treated as L1 plus L2 minus 1, which will make it 6. And hence, we know that the starting point of the output sequence will be computed using the sum of the starting point of x of k and the starting point of h of k, which is 0. So as you have noted with these two sequences, x of k begins at the position 0. Since there is no explicit arrow, it is assumed to begin at 0. And similarly, h of k also begins at 0. So the sum of the starting point of the output will be 0. So basically, as implied earlier, your y of n output will be consisting of 6 samples starting from y of 0 to y of 5. Okay. And before moving ahead, we need to have an idea about what is k, the range of k, because you have a summation term which depends upon the value of k, and k ranges from 0 to 3. So k basically is a range of the input signal, and since k starts from 0 to, with 4 inputs over here, it starts from 0, 1, 2 and 3. So the range of k can also be assumed as 0 to 3 over here. It is not a concern for the tabular method. So far our concern would be the output and its length and its starting point. So that we have already described over here. Now to find out this answer using the tabular method, you need to use a sort of table like this, where you write the corresponding inputs 1, 2, 3 and 4. If you want, you can draw it using a broken line. Highlight it using a broken line. So that it will help you in understanding, but not recommended. You can do it in much faster way also. So you write the other set of elements on this particular axis and you draw the broken lines too. Okay, fine. So what we do is we cross multiply the elements. We have 1 over here. We have 5, we have 7, then we have 2, then we have 10, and then we have 14, and then we have 3, then we have 15, and then we have 21, and then we have 4, then we have 20, and then we have 28. So 1 into 1 is 1, 1 into 5 is 5, like that. 2 into 1 is 2, 2 into 5 is 10. We go like that. And what you need to do to compute the result will be you connect the diagonal elements. So these are I'm drawing the line like this. Okay, now I have drawn diagonal lines which separate the elements. So basically, if you look here, you have got a combination of some 6 elements, and if you look over here, y of 0 can be treated as a 1, that is occupying this cell, so it will be 1. Y of 1 will be the next elements in the between these two diagonal lines, so it will be 2 plus 5 equal to 7. Y of 2 will be equal to the next set of 3 elements, that is 3 plus 10 plus 7 equal to 20. Y of 3 will be equal to 4 plus 15 plus 14 equal to 33. Y of 4 will be equal to 20 plus 21, which is equal to 41, and your last element, that is y of 5, will be equal to 28. So all in all, you have found out the 6 elements: 1, 7, 20, 33, 41 and 28. So the overall result of this linear convolution can be depicted as below. Y of n is equal to 1, 7, 20, 33, 41, 28. So this becomes the result of your linear convolution, and it is computed using the tabular method. Now if you look over here, as mentioned previously, your y of n would have got 6 elements, which was already computed over here, and here you can see that there are 6 elements over here, and then you have each of these elements starting from 0. So basically you can note that the signal will be starting at this point where the 1 corresponds to the 0th element. Moving on, we are going to solve this problem, the linear convolution problem, using the formula method. And now you have the two sequences as x of k, that is 1, 2, 3, 4, and h of k is 1, 5, 7. And using the tabular method, we had seen that y of n is 1, 7, 20, 33, 41 and 28. Now what we are going to try now is use a formula method. So before getting into the formula, this was the one that we are supposed to do. Y of n is equal to summation k equal to minus infinity to infinity. This is x of k, h of x of k into h of n minus k, and similarly this will be also k, since the signals are given as x of k and h of k. So x of k remains over there. Now to move ahead with the problem, we need to have an idea of what is x and what is k. So k, as you know, is the range of the input signal, which is 1, 2, 3, 4 over here, and its position will be, x of k is 1, 2, 3, 4, which means the positions will be starting from 0. So 0, 1, 2 and 3 basically. So k will be from 0 to 3, and now n is the range of the output signal, and it will be ranging from 0 to 5, because we know the output consists of 6 samples and it consists of range 0 to 5. So, and moving ahead, we can rearrange this formula as y of n is equal to summation k equal to 0 to 3 x of k into h of n minus k. So we know that we are supposed to find out the output. So the first output that we are going to find out is y of 0. So to find out y of 0, we'll have summation k equal to 0 to 3 x of k into h of n minus k, that is 0 minus k. So that will become summation k equal to 0 to 3 x of k into h of minus k. So when we expand this particular formula, we can see that it becomes summation, no need of summation anymore, we'll just substitute the value of k and solve it. So when k is 0, it becomes x of 0 into h of 0 plus x of 1 into h of minus 1 plus x of 2 into h of minus 2 plus x of 3 into h of minus 3. Now when we compare these signals, our values for x of 0 will be 1, h of 0 will be also 1, which can be understood from here. So this is h of 0, this is x of 0, x of 1, x of 2 and x of 3. This is h of 0, h of 1 and h of 2. So h of 0 is 1. So we complete this term. X of 1 is 2, but h of minus 1 is not given over here. We have only h of 0, which is the starting point. So that can be treated as 0. X of 2 is 3, but again h of minus 2 is not available, so it will be 0. And then x of 3 will be 4, and hence h of minus 3 is also 0. And all in all, we get the output as 1, which is again the same output that we have over here. Similarly, moving on, we'll try to find out what is y of 1. And when we substitute for y of 1, we get it as summation k equal to 0 to 3 x of k into h of 1 minus k, where n now becomes 1. So when we substitute for the values of k, we can see that when k is 0, it will become x of 0 into h of 1. When k is 0, this becomes 1 minus 0 equal to 1 plus x of 1. When k is 1, it becomes h of 0 plus x of 2 into, when k is 2, it becomes h of minus 1, and when it is becoming 3, it becomes x of minus 2. So when we substitute it with the required value, we'll be able to find out that x of 0 is 1, h of 1 is 5, and x of 1 is 2, and h of 1 is 1, x of 2 is 3, and h of minus 1 is 0, and x of 3 is 4, and h of minus 2 is 0. So all in all, when we add it, we get it as 5 plus 2 equal to 7, giving up the answer, the second answer. Moving on, we'll go for one more solution. All people who are watching should be able to solve it. We'll go for the final one, that is y of 5. And when we speak about y of 5, it will become k equal to 0 to 3 x of k into h of minus 5 minus k. So it will become x of 0 dot h of 5 plus x of 1 dot h of 4 plus x of 2 dot h of 3 plus x of 3 dot h of 2. So when we substitute these values, x of 0 is 1, h of 5 is not available, so it will be 0, plus x of 1 is 2, and h of 4 is 0. X of 2 is 3, and h of 3 is 0, because there are no values. H of 0 lasts only from h of 0 to h of 2. So then the last comes value at 4 dot, which means x of 3 is 4, and h of 2 is 7, which means it will be 28. And see, we have got that answer over here. So this is how we solve this particular technique using the formula method. So far we have looked into linear convolution, and we have looked into the case where linear convolution is done using the tabular method as well as the formula method. In the next method, next video, we will look into the graphical method.